Welcome everyone to today's video. We are going to discuss a question which uh, has been given fairly frequently in various exams. So that question belongs to the chapter of uh, work energy. So we have a spring system like this, and we have a block. So basically, we have four springs and we have a single block. Spring constant of each spring being k, and the mass of the block being m, right? So the question is, if this whole system is placed on some smooth surface and the force on the block is increased uh, linearly from the value 0 to f, then with how much distance the mass m would shift from its initial position. So at first we need to get our initial condition. So initially all the springs are in some zero tension situation. When we increase the force acting on the block, a tension develops in each spring. This tension we can simply evaluate by using um, balancing of forces or Newton's second law. We'll say, let's say tension acting in this spring is some T. So tension acting in this spring is T, and T. This spring is also producing a force T and T. This spring is also producing a force. So this has the tension T, right? So if this tension is T, these two tensions are going to be T by 2 and T by 2 respectively. Similarly, this tension is also going to be T by 2 and this tension is going to be T. So to see it clearly, why is it happening? If there is a pulley like this tension is T by 2, this tension is T by 2, then this tension is going to be T. So corresponding to that, we can say if there is an extension in, let's say, this spring, in this spring there is some extension, let's say x. So it would follow the idea that T by k would be the extension in that spring. Let's say that is x dash. So something like that. So what we want to find is the distance moved over the block x. We'll say that since the force is increasing from 0 to f linearly, the average force acting on the block is f by 2 and the distance moved by the block is x. So this is the total work done. All the work done would be stored as spring potential energy of all the springs. Spring potential energy of each spring is simply the tension in the spring squared divided by 2 divided by the spring constant k. So for all the springs which have tension T, that is this spring and this spring, the spring potential energy stored is this. If the tension is T by 2 So T by 2 square divided by 2K. This is the energy stored in these two springs. So this would become some T square by K plus T square by 4K. So this is 5T square upon 4K. This is the total spring energy. So we'll say T. So this is the final answer which I get. So thank you for joining.